Okay, for our second geometry video, we're going to be talking about some vocabulary and some of the words you're going to want to know. So for instance, we're basically talking about segments. And remember, segments are lines that end in endpoints. So here's our segment. There's the endpoint. There's the endpoint. This is a segment. And let's go ahead and label our endpoints. This is going to be A, and this is going to be B. Okay. So the first thing I want to talk about is the distance between A and B, right? So A and B are points, they're coordinates. If we think about them on a plane, on a coordinate plane, they might have an X and a Y value. Okay, but essentially they're points in space, and this can be x1, y1, and this can be x2, y2, just to differentiate them. Okay, so when I say distance, what I'm going to be talking about is the distance between x and y and y. So I can represent that algebraically, if you remember from last year, as the difference in the x values and the difference in the y values. Okay, and that's going to give us our distance xy's, and that's going to give us our distance yy's. Okay, and it's always the absolute value of those quantities. Distance from there, distance from there. Now this is only distance as an xy, but what if we're talking about the distance, let's say, on a diagonal? Well, this will give us this distance here, and this will give us this distance here. And to find this distance here, we're going to have to use some Pythagorean theorem. But just be aware of what distances mean, what we're talking about with distance. We're talking about the distance from one point to the other. We can also call that the length, by the way. So length is the length of a line, or the distance between A and B. Okay, that's the length, the distance between A and B. And it depends, right? Here we're talking about distance sort of as a point change in x, change in y. But here, when we want to find the actual length of this point, here when we want to find the actual length of this line, we're going to have to be talking about it in terms of Pythagorean theorem, which we'll get into a little bit later, or you might remember from last year. Okay, but just know the definition of these two words. Length, distance, is the distance from point A to point B, which is also the length of the line AB. And when we're marking a line segment, the way we always mark that is we put a line over the top without any arrows, just like that. So line AB. We can also just say, if it's length AB, you can also write that as just AB. When you're doing proofs and when you're doing math with it, you can say, okay, if I'm talking about the length of AB, I can just write that as AB. If we have two segments that are the same length, we can mark that with hash marks. And these we call, or tick marks, we call these congruent segments. And that means same length. And that's really the only determining factor in terms of congruence of segments. The only determining factor is the length. And we can mark that with these tick marks you see here. That and that just means those are congruent segments. They might not actually be congruent segments, obviously, but the tick marks say, okay, geometrically speaking, for the purposes of this problem, those are congruent segments, and we have to move forward with that in mind. Let's say we have a line. Let's say we have our old friend AB back. And let's say, for the purposes of discussion, we have this other point, C. Okay? And we want to say somehow that C is between A and B. So we want to say, and you look at this picture and you're like, well, obviously it's between, quote unquote, A and B, but How do we say that? Well, that's where this thing called the segment addition postulate comes in. And remember, a postulate is something we don't have to prove. We're just going to assume is true. So a segment addition postulate. The segment addition postulate says that C is between A and B if AC, so that distance, that length, AC, plus CB, that length, equals the total length of AB. So let me color this in just so you can see. So they're saying this, A, this distance here to C, which is this here, AC, and C to B, which is that distance there, is equal to this whole distance here, AB. Which it's obvious here that that is the case, and we could even put in our tick marks, which we just talked about, to say, yep, those are, oh, sorry, no, tick marks don't go there. We don't actually know that they're equal. What we know, though, is that we know that the sum of these two, so the sum of these two, A, C plus CB, is equal to, is congruent with AB, which makes sense. Not necessarily that the two segments are equal, because that would mean C is a what? If this were the case, if these were equal, this and this, that would put C as a midpoint, which is a different postulate. We often refer to the segment addition postulate in proofs as SAP, and that's okay. You can do that. SAP is sort of the common name for segment addition postulate. That's a fine way of referring to it. So let's talk about midpoint. Let's say we have our old friend AB back, and we want to know if C is a midpoint of AB. There's a couple of different ways we could know. If we know that these two are congruent, so AC is congruent, and congruent has a little bit of a different sign to it. Congruent looks like an equal sign with a wavy sign above it. If these two are congruent, then C is a midpoint. We could also say if AC equals CB, talking about their lengths, that would also mean that C is a midpoint. C basically has to bisect. A midpoint bisects a segment. What you may want to ask yourself is, why does it have to be a segment? Why don't we say line there? Think about that. Think about why lines might not have midpoints.